Okay, good evening all of you. Let us consider this circuit. Okay, Akshata, can you unmute yourself?
Yes, sir.
Yeah, fine. We know that this is CS amplifier. Can you reduce the sound there?
Sir.
Fine. This is CS amplifier, no?
Yes, sir.
No, Akshata, okay. I am getting the echo of my own noise. Are you turned on your speaker there? Hello.
Sir, I have connected my earphones.
Okay, now it's fine. I'm not getting. No, still there is echo. Are you not getting the echo?
No,
Barakalama.
sir. No, sir.
Somehow I'm getting it. Hello. I think now it's fine.
Yes, sir.
Illama. I'm getting somewhere. Let me see what to do. Okay, mute all. Now you unmute. Okay. Hello.
Hello. Yes, sir.
Where I'm getting the echo. Ankita, now you unmute. Hello.
Yes, sir.
Gagana, can you unmute? Hello.
Hello.
Yeah, now it's fine. This is a CS amplifier. So we have R1, R2, RDCC, and the MOSFET. This is the input voltage. I'll be getting the output at the drain point. So what are these? Okay, three frequencies. Cutoff frequencies of the frequency response of CS amplifier, corresponding to where does the slope of the frequency response changes. Am I correct? This
Yes,
is
sir.
F1, this is F2, and this is F3 like. And we also know that it is what is that voltage gain, which is V naught by V in is given by minus Gm into Rd, and this Vd, that is voltage at the drain point, is given by Vdd minus Id into Rd. So why these two are important? Because these two are important, or especially this particular equation is important, which will tell me how does, one second. Okay, this is 0, this is VDD. We're going to have this as VDS saturation. Shall I say this is VD, and over and above this will change? Am I correct? Who is there with me, Gagana?
Yes, sir.
Okay, around this VD, this will going to swing. Correct?
Yes, sir.
Now let us see, if I increase RD, what will happen? If I increase RD value, what will happen?
The
What all things will happen? Does the gain increase?
Yes, sir.
Does this VD, what will happen to this VD?
VD will decrease.
One second, just a minute. I'm getting a call. Yeah. If your RD increases, does this quantity increase? Hello. Hello. Okay, one second. Why this is okay? If I increase the value of RD, does this VD comes down?
Yes, sir.
Does this VD reduce?
Sir, video is stuck.
Video is stuck. What about why? How about now? Stuck.
Yes, sir.
Okay,
Too much, sir.
what can I do is let me stop sharing. Hmm, how about now? Is this fine now?
Yes, sir.
Okay. Now this is actually ID into RD,
Yes, sir.
correct? Suppose if I increase RD, does this come down? Correct?
Yes, sir. It will come down.
It will come down. And suppose assume that this was the you had some available swing. Assume that okay, this was available swing, and here it was more, means okay, wherever it is less, that will be the available swing. Am I correct?
Yes, sir.
Out of these two, okay, this peak and this peak, whichever is less, we'll consider that into two times will the available swing. Suppose if I increase the value of RD, does this comes down? Does this VD come down? Hello.
Yes, sir. It will come down.
This is keep on coming down. Of course, what are the advantage of increasing RD? The gain will increase. Even though gain is increasing, since this is coming down, you don't have enough swing. Am I correct?
Yes, sir.
So the increase in RD may increase the gain of the amplifier, but the available swing is keep on reducing. Am I correct?
Yes, sir.
So do you mean to say there is a limit for increasing the RD to get larger gain? Because assume that I want to get a gain of 50, 100, 200, 300. Is it possible now? Assume that with a gain of 10, it is somewhere here. With a gain of 10 volt per volt, it was somewhere here. Suppose if you want to make it 50, what do you have to make this? This RD has to be increased by 5 times as per this. Correct?
Sir, again it's stuck.
Oh, I don't know what is the problem. It is also in strike, even though I am allowing, okay, considering myself to teach, video is not allowing. How about now? Let me just check out. I think now it's visible. It's
Yes,
fine.
sir.
Okay, this is fine. Now you can see, assume that earlier the gain was 10, that is minus 10 volt per volt. So I was getting assumed that okay, this was there at the midpoint. Suppose if I want to increase the gain to 50, that is I want to increase RD by 5 times so that my gain becomes 50. So when I'm increasing this by 5 times to 50, does this come down very drastically down here?
Yes, sir.
So in such case, even though you might have increased the gain, since you are unable to get the swing, it's of no use. Am I correct?
Yes, sir.
No. Even though it is capable of giving larger gain, but since the whatever swing that you have across the RD, since it is not feasible to get the gain, sorry, it is not feasible to get the desired swing, then you cannot get it something like this. Is it possible to get something like this?
No, sir.
Here it is clipped off, here it is fine. So this is not advisable. So what is the best thing to have is, I need to have, if this is the available volt, sorry, the minimum voltage to keep it in saturation, I had to always keep this at the middle, and then I should be keep on changing this. Correct?
Yes, sir.
What I mean to say is, by increasing the value of RD, it is not advised to increase the gain of the amplifier. Correct? Now,
Yes, sir.
can I increase GM now
Yes, sir.
instead of RD? How do you increase GM? How do you
By
increase GM? What is GM is equal to?
Siemens.
Am I
My
correct?
increase ID.
Correct? So
Yes, sir.
you can increase ID, you can increase W by L. Of course, increase in W by L is nothing but that will increase the value of ID. So does this ID increment by some means of increasing R2 or by increasing W by L, will it not again reduce the value of RD, sorry, VD? Even though, of course, here you can see what is VD here? VDD minus ID into RD. In the first case, we try to increase this. When we try to increase this was coming down. Am I correct? Hello.
Yes, sir.
Now
Yes, sir.
we want to somehow increase the gain. We found that okay, increment of RD is not recommended. What is the other possible value to increase the gain? What are the two parameters we have?
Increase in GM.
Increase in GM.
GM.
But even the increase in GM will again affect my VD. Correct?
Yes, sir.
So it is very difficult to get larger gain with this type of amplifier. Correct? Why
Yes, sir.
it is not possible to get larger gain? Because this VDs keep on going down, which will have a limited swing for your output voltage. Correct?
Yes, sir.
So we have to find out some means so that you can able to get larger gain also, and it should be there exactly at the midpoint. It should be there exactly at the midpoint. So let us find out the ways and means. How do I get that particular point? Or that type of circuit. Now we can see we have to find out some resistance which should not consume too much voltage but should give larger resistance value. Getting the point? Now I have to
Yes,
have
sir.
some load. So this is, I'll call it as R load. Let me call it as this is VDD. Now this is R1, R2, CC so also. Now this is V0. What is this now? Now it is not a resistor. I'll simply call it as load. This is a load. What is the requirement of this? This should have higher resistance value but low voltage drop. Suppose if the resistance is more, voltage drop will be usually more. Suppose instead of this load, if you put a resistor of larger value, what will happen? The voltage drop will also be more. So I need to have a different type of load which can offer higher resistance but require or consume lesser voltage. So let me just show you something like this here now. Okay. You know that okay, this is an NMOS transistor. What was the equivalent circuit of this? If this is what? Drain, source, gate, do we used to write something like this? GM into VGS. This is what? Gate, drain, source. Am I correct? What is that? What is this? This is visible, no? Hello.
Yes, sir. Now visible.
What is this? Oh, so far it was not visible.
No, sir.
You have to say something, no?
Sir,
Otherwise,
it was stuck like
you have
the
to say that
previous
also.
one.
You have to say that also. Otherwise, how do I know? Is this now okay?
Yes, sir.
Okay. Is this GM into VGS, gate, drain, source? Correct?
Yes, sir.
Now,
Yes.
what is the assumption here now? The assumption is something like this. It is a constant current source where lambda is equal to 0. Am I correct?
Yes, sir.
What is on x-axis?
VDS high.
Correct? Yes?
Yes, sir.
Suppose if it is a non-ideal characteristics, does the graph goes like this? Does it go like this? This is for lambda non-zero.
It's
Correct?
not visible. Yes, sir.
Is it non-zero?
Yes, sir.
I can see it is keep on increasing.
Yes, sir.
How do we represent this in the small signal model? So are we not putting a resistor R0 here?
Yes, sir. We are putting.
Correct? So this is what representation of a current which is increasing as you increase the VDS, as you increase the value of VDS. Correct?
Yes,
Now
sir.
this is for NMOS transistor. On the same lines, if I write it for PMOS transistor, where PMOS it is like this. You can see this is source, drain, gate.
Gate.
This is PMOS. PMOS structure would be something like this. This is now P plus. P plus, you're going to have the gate structure, of course oxide gate. This is gate, this is source bar drain, this is drain bus source, this is N minus substrate. Okay, now the equivalent circuit of this would be something like this. This is gate, source is always at higher potential. Now we can see I'm writing it like this. This is Gm into VGS. This is source, because you can see source is at a higher potential. This is gate, this is drain. Correct?
Yes, sir.
Now on the same lines, this is okay. For NMOS, all are positive voltages. This is positive, this is positive, this is positive. For PMOS transistor, everything is negative. See now, this is ID which is negative. This is VDS which is negative. This is VGS which is negative. See now, if it is lambda equal to 0, it is flat. If lambda is non-zero, this is something like this. It just goes like this. See now. So shall I represent this also by a resistor R naught?
Yes, sir.
Now as we did it for this, it is exactly the same way. Correct? Here also it is from
Yes, sir.
drain to source, here also it is from drain to source. Correct?
Yes, sir.
See now, this is a current source. This is what? Voltage dependent current source. The voltage is small signal voltage. This is small VGS. See now, this is small VGS. This is not a DC voltage. This is a small VGS. Correct?
Yes, sir.
So what we'll do, we were having this circuit, no? We were having this circuit. Let me rewrite this load. Okay, we simply assume that some load. Let us try to have the load in the form of a MOSFET. See now, I'll write R1. This is R2 as it is. I will write, let me write it as M1. This M1 is as it is. You can see now, this is M1. And I will write one more transistor which is now M2. So I can see this is M2. This is having some bias voltage. Let me call it as VB1 or VB2. See now, this is PMOS transistor. Now to this transistor you are applying the input voltage. See now, it is V in CC. There is a bias voltage here. This is what? R1, R2. Here you are again
Sir,
taking the
how
output
do we
voltage.
get?
How do
Sir,
you get?
how do we get to know that it has high resistance and voltage drop is low?
We'll see that. We'll see that. I'll come to that. I'll come to that. Now that's what is the requirement. Requirement is that, okay, why we need to have higher resistance? We want to, of course, this is the requirement. Why the resistance should be high? Why the resistance should be high? Because I have to get larger
So
gain.
they
Because I have to get larger gain. Why the swing? Why the output? Why the drop should be less? Why the drop should be less? So
to
that
get swing.
it won't consume too much. So that I can get good swing. Am I correct?
Yes, sir.
So these are the two requirements. So it should not consume too much too much voltage, and it should have very high resistance. Is that fine? That is a
Yes, sir.
requirement. That requirement I cannot fulfill using a passive resistor. Suppose if you use a passive resistor, you may have a larger resistance value, but the voltage drop will not be too much. Am I correct?
Yes, sir.
That will actually reduce my swing. So that's why we are going away with this RD for larger gains. You will never use a passive resistor for larger gain. So we are using a different load in the form of MOSFET. This we call it as active load. What is this name called? It is active load because the MOSFET is an active element. It is now acting like a load. Getting the point?
Yes, sir.
This is a load. This is a what is that? I'll call it as an active element because here also there's a MOSFET. Here also is a MOSFET. The role of MOSFET here is to amplify. The role of MOSFET here is to act like a load. Correct?
Yes, sir.
Now let us see what happens. So shall we start writing the equivalent model of this, equivalent circuit of this?
Yes.
So what it is, okay, again the same procedure, short this, ground this VDD to so and so, because this is already grounded. You replace this by its small signal equivalent, you replace this by its small signal equivalent. So
Sir,
before
it's
I
stuck.
again stuck.
Video
The
is stuck,
screen is
sir.
not working,
Sir,
sir.
again is stuck.
Wait, I'll do it. No, I think no, it's fine. Hello. No,
No, sir.
wait, it'll come. Okay, now it's fine. Correct.
Yes, sir.
Now let me just again rewrite that. This is my CS amplifier with active load. You can see I'm just shorting here. This dark indicates that there is a connection. Correct. Again there is a connection here, grounded. This is NMOS, this is PMOS. I'm writing some VB2. This is DC voltage, and this is VDD. This is VDD, and here I'm taking V0. This is CC. Correct. This is R1,
Yes, sir.
R2, V in, V0. Done. Let me name it as M1, M2. Correct. Now
Yes, sir.
let me write the equivalent circuit of the known thing. So I will retain this input voltage as it is. Shall I make this R1, R2 parallel and then put it down like this? Can I?
Yes,
This is
sir.
R1, R2. How about this MOSFET? Shall I represent this MOSFET by GM into VGS1? Let me call this as VGS1, and then R0 1. Assume that the lambda in both the
Again.
cases are non-zero. Correct.
Yes, sir.
This is my MOSFET. Am I correct? What is this? Gate, source, drain.
Source.
Correct. Then we
Yes,
have to
sir.
do it for this. MOSFET. How do we do it for this MOSFET? You can see, suppose if it was a MOSFET, okay, how did we wrote for this? So I think we wrote it here like this. Am I correct here? For a MOSFET,
Yes, sir.
for a P MOSFET, if it is source, drain, gate, if there is a small input voltage Vin applied, so it would have been so and so. Correct? This Vin is nothing but, okay, of course with respect to VD you take it as, so this is now VGS. So whatever input voltage you are applying is across this one, if I connect it to VDD. Correct?
Yes, sir.
Now I have not connected anything here. See now, what the voltage you have at the base? Sorry, what is the voltage that you have at the gate? This is DC voltage. Correct?
Yes,
Hello.
sir.
Is this DC voltage?
Yes, sir. It's
Okay.
DC.
Let me just rewrite the same thing. I now I'm writing it for the PMOS. Is this again drain here? Drain, source, gate. Am I correct?
Yes, sir.
Okay. Let me just take. I'll just move this above now. This is what drain. Is this GM into VGS? This is source, and do you say this is gate? Shall I say this as R02, and this is again grounded? Am I correct?
Yes, sir. It's
How about this? Is this also not grounded? Gate. See
yes,
here,
sir. It's also
for the gate, what do you have? You have a DC voltage. Have you not grounded the DC voltage for
Yes,
writing
sir.
the AC
Grounded.
equivalent? See here, this is that VDD. I have grounded. This is also DC voltage. Shall I ground this also?
Yes, sir.
So are this voltage at the source and gate 0 volt?
Yes, sir. It's 0.
Is this VGS is equal to 0 volt?
Yes, sir.
This is VGS what? Small signal voltage. because whatever we are writing is a small signal model. So is this voltage 0? Is this voltage 0? Does it mean that small signal between gate and source of PMOS transistor is, are you applying any input here in terms of AC?
No, sir.
That's why it is 0. That's why VGS is 0. If this VGS is 0, how does this will look like? Suppose if VGS is 0 for a current source, which is having GM into VGS, if VGS is equal to 0, how do you represent this current source by?
Open, sir.
Open circuit. So you open circuit that. Okay, what I'll do, I will rewrite the circuit. So I will rewrite this circuit. So I will write R1, this is R2, this is gate, this is source, this is what? GM into VGS. Okay, let me write as GM1. This is also GM1 because this is of MOSFET 1. So this is R01. So is this ground? Is this grounded?
Yes, sir.
Is this open circuit here? Here, of course, there is an open circuit. Does this also looks like open circuit now? Because VGS is 0 means, okay, this is like open circuit. This is like open circuit. So shall I write a open circuit here?
Yes, sir.
To ground. How about this? This is there as it is, no? Correct?
Yes, sir.
Correct. Now, is this R02 coming exactly in parallel with R01? See, this is ground. This is also ground. I just make both of them same. So when I'm just connecting this back to this, because these 2 points are same and these 2 points are same, is it not like, okay, R01 in parallel with R02?
Yes, sir. It's in parallel.
So now, can I rewrite the equivalent circuit for this particular transistor with active load as this is R1, R2, this is
Sir, it's stuck
R01.
now.
Wait, let me just rewrite it, and then GM1 into VGS, V0, Vin. Okay. Let me just wait. I'll stop this and again share it. Okay, is this visible now?
Yes, sir.
So is this VGS now? Now I will say this as GM1 because it is of MOSFET 1. This is M1, this is M2. So since it is of M1, I will write it as R01. Since this is for M2, I will write it as R02. If it was simply M, I would have written it as simply R0 and GM. Since we have suffix as 1, 2, I will write GM1. Of course, this GM2 is actually what? So this is open circuit. This is not at all coming into picture. So now what is the gain of the amplifier now? So what is V0 is equal to? Is not V0 is equal to minus GM1 into VGS into R01 parallel R02.
Yes, sir.
You assume a current of I0. That I0 is in the opposite direction to this. This is GM into VGS. That's what GM1 into VGS. What is the resistance you have?
R01 is parallel with R0.
R01 parallel. So shall I now write V0 by Vin is equal to minus GM into what? R01 parallel R02.
Sir,
Now,
it's again stuck.
okay, let me just check it. I'll just is it fine now? Let me just link it. I think now it's fine. Correct.
Yes, sir.
Now, what is this circuit now? This one to start with. What is the circuit there? Hello. Something is stuck. What is? lagging too much. Yes, sir. I don't know where is the problem. Problem is somewhere. I don't know where the problem is. Okay, what I'll do, I'll just close and open it again. All of you rejoin it. I will leave the meeting. I'll just what I'll do
From
is
morning itself.
what?
From all sessions are having same problem, sir.
What to do? Problem with you people. That's why there's a problem with WebEx also. Problem is there at one point. It will just go everywhere. So what I'll do is I'll just close and then you all of you rejoin it. Leave the meeting and then again join it. Will it solve the purpose? I don't know. Let me see. Stop sharing. Let me end the meeting. Ending it now. Let me again go back. Not here. Again, let me start the session. Okay, shall we start? I think now it's visible. Is it better or the same? Can I take someone else? Okay, Reshma.
Yes, sir.
Yeah, fine. I think now it's better. I don't know how the condition is. So,
Yes.
of course, we were trying to write the small signal model for this particular CS amplifier with load as a P MOSFET. Correct?
Yes, sir.
Is that lagging still there? Not that much. Huh? Who is there
Yes,
with
sir.
me? Reshma?
Yes, sir. It's better.
Better. Okay, fine. So you can be a bit louder. I know it's already 4:30. You're all tired. Okay, now can I write the small signal model of this particular amplifier with this as an active load? Can I write it this way over here? Hello, hello.
Yes, sir.
Matadama. Just keep on. Unless otherwise, how do I proceed? So shall I now write finally the expression for this amplifier with active load as minus GM into R01 parallel with R02. Correct?
Sir, it's not visible.
Stuck? Video is stuck or what?
Yes, sir.
Okay. I'm trying to share the video again. Fine.
Yes, sir. No
Okay,
issues.
is this fine? This is the circuit for, or this is the equation for voltage gain for a circuit which is something like this.
Hello, sir.
Correct? Is it fine?
Yes, sir. Sir, it's
Uh,
lagging, sir.
at least it is visible, no? Fine. Even if it is lagging, so at least now you people uh, try to, okay, corresponding to M1, I will write it as lambda 1 is non-zero. Here lambda 2 is non-zero. At least my voice is not lagging, no?
Yes, sir. Voice is
Voice
clear,
is fine,
sir.
okay. At
Yes.
least you people just listen to me. Okay, once I share the video, you can able to clearly see it. Now, these two are having some channel length modulation. That's why lambdas are non-zeros. So it can be 0.1, it can be 0.01, it can be any value. Correct?
Yes, sir.
Instead of having this as a active load, if I have it as a resistive load, with still this as lambda as non-zero. So shall I rewrite the circuit something like this? I just want to connect you people, okay, with active load and with resistive load. How does it look like? This is again VDD. This is V0. This is RD. This is R1. This is R2. This is only M1. Am I correct? What is the difference here, Reshma?
Yes, sir.
What is the
Only the
difference?
circuit.
Here also lambda is non-zero. What is the difference? The load is resistive. The load is active. That is the only difference. Correct?
Yes, sir.
Now, how does this difference will reflect in your expression? This expression will become same minus GM1. R01 is as it is. Instead of R02, it is RD. Correct? This is for this circuit. This is for this circuit. Correct?
Yes, sir.
Is it fine?
Yes, sir.
Okay. Now, let us try to see how much is, what is the voltage that VD you will have here and what is the voltage VD you will have here. Now we are talking in terms of drain voltages at this point and this point. Fine? Hello?
Yes, sir.
Okay. Now, over here, do I need to keep some voltage to keep it in saturation here, this M1? Here in this case. Correct?
Sir, nothing is
Stuck.
visible. Yes, sir.
Oh, बाप रे, क्या करें? Why it is such a problematic thing today? Okay, let us see. Let us see. Can I able to share it? Having network problem to connect. Okay, I think now it's visible. Reshma ji?
Yes, sir. It's visible.
Okay, now shall I write this as VDD and this as VD point? This is IDRD. Can I?
Sir, no movement is there. Only.
Can you see this block now?
Yes, sir.
Is this VD visible, VDD, and then required voltage to keep the
No,
MOSFET in
sir.
saturation? No. Is it visible? Speak out.
No, sir.
ಇದೇನು ಕಾಣ್ತಿಲ್ಲ. What happened? Just put in the chat box. Is it visible or is it stuck?
Stuck, sir.
Is it stuck or what?
Stuck,
Trucks.
sir.
Ayyo.
That's it. Only one photo is playing. I think so.
The
It's not
box
moving.
photo is
Now something again.
now
No
it's
ID is
After 1 to 2 minutes, the photo is changing.
Oh, 1 to 2 minutes, 120 seconds.
2 delays.
Maybe it's our fate. The pace you are learning, the pace we want you to learn is too different. In spite of doing switch on, switch off, share, not share. Now the same thing. How about now?
yes,
just
sir.
still the same thing.
Only photo is visible, sir.
One?
Only photo is visible, sir. No
Which photo?
movement.
Okay, I'm not making
Cursor
any
is
movement now.
moving, sir.
Is this fine now?
Of course.
Of course, I'm not making any movement. That's why it is still. How about now?
Yes, sir. It's
Yes,
okay.
No,
sir.
it's
Is
kind
it
of
fine now?
okay.
Slow motion like, sir.
कुछ तो दिख रहा है ना बस.
Yes, sir.
Okay, fine. Now this is how the swing will look like. So let us try to write the same thing for this here now. So what I'll do, I will write it for this. Is it 0 VDD here? 0 on VDD.
Yes, sir.
Do you have one MOSFET at the bottom side and one towards the VDD side?
Yes, sir.
So do we need to keep some voltage to keep it in saturation and some minimum voltage to keep the other transistors also in saturation?
Yes, sir.
So shall I dedicate some voltage over here to keep the MOSFET in saturation so that I cannot enter here? Can I dedicate the same voltage on the other side so that I can keep both the MOSFETs in saturation?
Yes, sir.
See, this is dedicated for PMOS. This is dedicated for NMOS. How much you have? You have this much swing available. Now you keep your VD at the midpoint and then keep swinging. Keep it at the midpoint and keep swinging. Correct?
Yes, sir.
Now let us take an example of ID is equal to something like 1 milliampere. Let us take an example. Correct? And
Yes.
lambda is equal to 0.01 volt inverse. See now, these are the values of ID and lambda. Correct?
Yes, sir.
You can be a bit louder, whoever is speaking. Reshma, you just hold the mic closer to you.
Okay, sir.
This is better. ID is 1 milliampere. Lambda of both N and P, let it be 0.01. Correct?
Oh, okay, sir.
So now what is the value of R0 is equal to, is it not 1 over lambda into ID? If I not derived it, okay, let me just show the derivation sometime. Of course, derivation is not very important, but okay, R0 is given by 1 over lambda into ID. So does the, what is that, units match? What is the unit of lambda? Volt inverse. I have written no?
Volt inverse.
Volt
Yes,
inverse.
sir.
Volt inverse means will it become volt here? Because this volt inverse it will go to
Yes, sir.
volt.
Inverse.
What is the current this one unit? A, ampere.
Ampere.
Will it become ohm now? V by I.
Yes, sir.
So is this R0 ohm? This is also ohm on either side.
Yes, sir.
Now with the value of lambda as 0.01 and the ID as 1 milliampere, what may be R0? Can somebody calculate what is R0? 0.01 into 1 milli. 1 over that. How much? Hello.
1 micro. Oh,
नहीं 0.01 into 1 milli and whole inverse. I don't have the calci. Let me get the calci.
100 kilo ohm.
Huh?
100 kilo ohm.
100 kilo ohm. See now R0 is 100 kilo ohm. Fine. This is now 100 kilo ohm. Let us take the example of this where RD is equal to 1 kilo ohm. Correct? Let us take an example. So if it is 1 kilo ohm, if the current flowing is 1 milliampere, what is this point? If it is 1.8, if it is 1.8 volt, is it at 0.8 volt? Because this is 1 volt, no? Getting the point?
Sir, video got stuck, sir.
Okay. Sorry for that. I don't know what is happening to this video. Now, is it now, Reshma? अभी ठीक है?
Yes, sir.
Now, if I assume this has to be 1 kilo ohm and if this is 1 milliampere, does this ID into RD 1 volt? What is 1k into 1 milli? That milli and k will cancel out and it will become 1 volt. Correct?
Yes, sir.
Again, hold your mic close to you, I say.
Okay, sir.
Just hold it close to your mouth. 1.8 minus 1, is it not 0.8?
Yes, sir.
So at 0.8 it will swing with some gain. Correct?
Yes, sir.
So now, what is this now? You have this as 100k. Am I correct? R0 is 100k, no?
Yes, sir.
What is this RD? 1k. What is 1k in parallel with 100k? It will be close to around 909 ohms or so and so. Correct?
Sir, again video got stuck.
Okay, fine. Okay, even if video gets stuck, now we have R01 into R01 parallel with RD. Am I correct as the load parameter? GM into.
Yes, sir.
So R0 is 100k, RD is 1k. What is the parallel combination of that? Can somebody say 100k in parallel with 1k? Is it not 909 ohms? 100k into 1k. Of course, 100k in parallel with 1k. ಎಷ್ಟು ಹೊತ್ತು ಮಾಡ್ತೀರಪ್ಪ 100 by 1
990 milliohms.
990 millina.
Milliohm. 10 power minus 3.
Hey,
100 into 100.
0.9 Ks
0.9
K.
what? Oh, 0.9k is 900 ohm.
Yes.
1 exponential 3 inverse plus 100 exponential 3 inverse of that is 990 ohms. Correct? Hello,
Yes, sir.
this is 990 ohms. Is it not close to 1k?
Yes, sir.
So the effective resistance is 990 ohm or close to 1k. Am I correct?
Yes, sir.
That multiplied by GM is the gain of the amplifier. Done? Hello.
Yes, sir.
Now let
Yes,
us go
sir.
to this active load. What is the resistance here? 100k. What is the resistance here?
100K.
That is also 100k. What is 100k in parallel with 100k? 50k. Is it not? If we have two
Yes, sir.
resistors of same value coming in parallel, the effective resistance is half of that.
Yes.
See now, the effective resistance is now 50 kilo ohm. Whatever GM you had, that multiplied by 50k, is it not very much greater than GM into 990 ohms?
Yes, sir.
Meaning that, shall I take this as almost close to 1k instead of making
Yes,
990?
sir.
Can you see GM is same here? Correct? Hello.
Yes, sir.
So GM in both the amplifiers, that is with resistive load and active load, is same. but you can see the resistance is 50k here, it is 1k here. Is it not very high resistance?
Yes, sir.
Are we achieving one of the requirement of high resistance? Hello,
Yes, sir.
video ಕಾಣ್ತಾ ಇದೆಯಾ?
Yes, sir. ಇಲ್ಲ, sir.
Okay, no, why we actually started with active load? Because we wanted to have very high resistance with very low voltage.
Resistance.
Correct?
Yes, sir.
We have not
Yes,
yet
sir.
seen whether it is consuming low voltage or not, or at least we are now very confident that it is giving very high resistance. Am I correct?
Yes, sir.
Why it is giving a very high resistance is because R01 in parallel with R02 is giving me 50k, whereas in the earlier case R01 parallel with RD was close to 1k. Is it not almost 50 times more?
Yes, sir.
So it is now 50 times more. So let me now show you whether it is consuming lesser voltage or not. Correct? So maybe for this I want
Yes.
to show you the video. Video is a must now. Let me just stop sharing and then reshare it. If I can able to show you that. Okay, let me see now. Sorry for whatever that is happening. Nothing is in our control. Unable to share it. Today is the longest day for you people, no? 12 to 12:30 batting, 4 to 5 o'clock again one more batting. It's like 2 super hours in a match. Okay. Oh, this is not at all sharing. Share the content. I am sharing the camera. Oh. Nothing. What is visible now? Reshma, what is visible?
Nothing.
Nothing.
Nothing, sir.
Okay. Oh, I think now it's visible. I think will it come after 3 minutes?
No, sir. Nothing is visible.
Still nothing is visible. Sharing. You are sharing camera. You are sharing camera. It is showing me. Is it not visible to all of you or only for Reshma?
No, sir, it's not visible, sir. It will
For
come
all of
after
you.
2 minutes.
Okay. Maybe it is time.
Now it's visible.
Is it visible now?
Yes.
Yes, sir.
Okay. Now, can you see now? As I said, at the bottom transistor, you need to leave some voltage for keeping NMOS in saturation. Correct?
Yes, sir.
Okay. On the P side, is it still what? Can you see there is some voltage required to keep the P MOSFET also in saturation? Because we have one MOSFET here, one MOSFET here.
Yes, sir.
Now, how much is the voltage that you require to keep this in saturation? If VGS is 0.6, is it hardly 0.2?
Yes, sir.
Over here, is it also 0.2? On the same lines, suppose the overdrive voltage is 0.2 here, does the overdrive voltage is again 0.2 on the other side also?
Yes, sir.
Now you can see out of 0 to 1.8 volt, so 0.2 left out. Do you have a peak to peak of 1.4 volt left for the swing if you are keeping this at 0.9?
Yes, sir.
See now, if I can be able to make this to a swing at around 0.8 volt, how much is available swing? It is 1.4. This transistor is offering very high resistance and it requires very small voltage to offer that resistance. Am I correct?
Yes, sir. Sir, video is lagging, sir. Nothing is visible.
Now at least could I able...
Previous image is there, sir.
Which image is there?
Previous, sir.
Previous, I don't know which is previous. Is that okay? Swing is there, point to point, whatever I've written.
No, sir.
That is not there. The previous and the how previous upon last class in the. Okay, fine.
Gain equations.
Is a problem
The
from
gain equations, sir.
gain equation.
The
GM1
gain equations useful.
R01
No,
paired
no,
with
that
R02.
one, sir. Yes, sir. That's
Yes,
there.
sir. Yes, sir.
That photo is useful.
Okay, what to do? Okay. So for the day we will end it. So when do I have class? Next tomorrow? No. So tomorrow we'll have a class at 12 o'clock. So it will be marathon classes, because unless you get hold on this one, you cannot survive. So tomorrow at 12 o'clock we'll have the class, and then try to make you people understand this. We'll do a simulation so that you can appreciate that having a transistor as a load can give larger gain without consuming too much voltage for keeping the MOSFET in saturation. Okay, if everything is
10 o'clock it's free, sir.
12 o'clock,
11 o'clock it's free, sir. No classes.
so then I'll take. You just keep on informing me at what all time you are all free. I'll be there. So at 11 we'll have it. Okay, fine.
Sir, at
Thank you.
11, network
11 we have
analysis. If you have
FMAT, sir.
NDA class, network
Then you'll have it at
analysis
12.
class.
I think 12 nobody has booked it. Booked you people. Huh? Is 12 fine? Is 12 fine? So you do whatever we know how to do it. Is that is the thing? Okay, tomorrow we are meeting at 12 o'clock. Thank you.